Okay, it's recording. I guess we're okay.
Okay, my awesome friends. Could you find the APYs for the other two? No math involved, right? Where did you go to look for the weekly compounding?
52 weeks.
Yes! Go right to 52 weeks. When you get there, it will tell you how much you have in your account after a year. Let's go look. 52 weeks. Scroll down. 52, here it is. If I scroll over, it looks like, depending on whatever formula you chose to use, you got about $102.02, which you know is more than $102, which means the APY is higher than 2%. So the question is, what is it? Now this is where the fun little increase decimal button comes in handy. You can actually increase the decimal a little bit and see, and you can go as far as you want. I mean, I don't know how far a bank would actually go. But now you can see what the APY is. It's 2% APR, but an APY, what it actually yields for you is that, about 2.019%. And I have no idea what it would round off to on a bank. I'm not sure if they would call that 2.02%, or if they would call it 2.0197. I don't know what they would call it. There's a lot of decimals there. You decide what you want to call it, what you want to round it off to. Okay. I think a bank would probably do 2. They seem to use 2 decimals of rounding, I think. But I like having more, because then you can see how the APY for the weekly is better or worse than the APY for the monthly. It's better. It's better. We already proved this, right? We proved this by looking at the final results. We know we're making more money weekly than monthly, and more money monthly than annually. So logic says we should also be making more money daily than weekly. Let's go look. Let's go look at daily. Yeah. What day I gotta look at? I think so. 365 is a year, yeah? Hells yeah. Let's find that little booger. There you are. It looks like 1.0202, or 102.02. It's rounding. Expand that puppy dog out. Oh yes. Oh yes. It is indeed a higher APY for daily than it was for weekly, and for weekly than it was for monthly, and for monthly than it was for annually. Which begs the question, as maybe an investor, can we do better than daily? I don't think so. Hourly.
Beat me to it.
Hourly, yes. Secondly, there is something called compounding continuously. I don't see it in bank accounts, but unfortunately things do compound continuously. Some good things and some bad things. Like fetal cell growth. That's a good example of good compound, but also cancer cell growth. They compound basically very continuously too. It literally like instantaneously doubling. So there's some, it exists, just not with finances. That would get us more money though. I mean, you could run the math on it if you wanted to. I don't think anybody does at this point. I think you've had enough of this, which is totally fine. You look exhausted. Okay. Last question on the quiz. And I think this is kind of a good wrap-up place for us to stop today. Why is everything we just looked at called exponential behavior of data? And then I put, how does it differ from linear and quadratic? So to help us, I put 3 minor, tiny, nice, friendly, easy to digest data sets on the sideboard over there. I'm going to swing the camera over so everybody can see it too. Is this thing in your way here, Jess? Is it okay with this? If I turn this to the side, is that okay? Okay, good. Marlene, is it okay if I just tilt this a little bit? Okay, thank you. I don't want to screw up what you all are. Oh, there's a glare on the screen. I hope everybody at home can see that okay. I need a budget. Okay, I think you can see that okay. One of these is linear, one of these is quadratic, and one of these is exponential. One of them is also wrong. No, I guess we're okay. It's fine. I did the math in my head wrong, but it still came out okay. Which one's linear and why? I need more color markers. I need more colors. Just black and
The first one?
Which one? I hear a vote for the first one? The leftmost one? Anybody agree the left one is linear? Go ahead and vote with your hands if you think the left one is linear. Okay, I like it. We got a nice almost. That was better voting than happened in the 2016 election. Well done, you. Yeah, you had more than half of y'all. Good. Who wants to tell me why it's linear? Who wants to tell me why it's linear? I agree with you all. Even though my head put the wrong numbers down, my subconscious put the right numbers in to make it linear. Tell me why it's linear.
Is it increasing by a constant rate?
Say that again, Austin.
Is it increasing by a constant rate?
So if you look at how the data is changing, it's perfect. There's a constant rate going on. For example, notice up 1, up 1, up 1, up 1. Now please notice I used the same input variables for all three of these. All of them, the input variables are going up 1, up 1, up 1, up 1, and also over here, up 1, up 1, up 1, up 1. I did that intentionally. I wanted that to be consistent so we could look at what was happening with the output variables. And Austin just nailed why this is linear. If you look at how the output variables are changing, the output variables are changing constantly with their rate of change. Constant rate of, and that really is the giveaway for linear. Linear has a constant, can I use the phrase A-rock? Or should I use something else? Rate of change, that's what you said, right, Austin? I'm gonna call it constant rock. Kind of like me, constantly rocking. That's terrible, okay. Thank you,
No problem.
that's beautiful. And that is the definition of what linear data does. What's the next one?
Quadratic.
You got a couple quiet votes for quadratic.
It is.
I agree. Tell me why.
Being multiplied,
Say that again, Ty.
it's being multiplied by the x, so it's like 1 times 1.
Oh, I like that. Good. Okay, so that's a really, really clear way of looking at it. You're taking the input variable, and you can actually view it as it's the input. Let's use a different color. What color you want, Ty? Green or blue?
I like green.
Green, you got it. 0 is 0 squared. 1 is 1 squared. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. Thank you. Say that again. No, I thought I heard something. Oh, I like your ideas. They're very, very good. That's perfect, by the way. Quadratics always aren't that obvious. I made this one obvious. I wanted it to be obvious. Does anybody remember, and it's okay if you don't, this was like 3 warm-ups ago. You can do A-rocks on quadratics, but may I erase this, the linear one now that we've talked about? Is it okay if I hate to do this, but we're out of board. I want to leave that one up there. I'll just erase it. So I'm going to bring this one over here. 0, 1, 2, 3, 4, 0, 1, 4, 9, 16. So this is X and this is Y, input, output. I'm going to go with the green again. We did, in a warm-up, a couple warm-ups ago, we looked at the A-rocks, up 1, up 3, up 5, up 7. They're not constant, but they're constantly increasing because they're going up by 2 here. And we called that something. Do you remember what we called that? It does have a constant, not an A-rock, it's a constant. It also starts with an A. Acceleration, Sophia, thank you. Quadratics have constant acceleration. So the big takeaway is that linear has a constant rate of change. Quadratics have a constant acceleration, which is also known as the change of the rate of change, which is kind of harder to say and also less obvious. Acceleration, I think, makes more sense. I think that means we know what the third one is. Exponential. Yes! Why is that one exponential?
Because the variable is an exponent.
Say it again, Jonathan.
The variable is an exponent.
See, the variables here are raised to the first power. As Ty correctly pointed out, the variables here are raised to the second power. An exponential function actually has a completely different placement for the variable. Let's look at the pattern here. This is 3. I want to use red to get your attention. This is 9 because that's 3 times 3. This is 27 because that's 3 times 3 times 3. This is 64 because it's 3, and that should be 81, not 64. Somebody should have caught that. 3 times 3 times 3 times 3. Does it fit up here? Yes. Now it's hard to write, but 3 is 3 to the first power. 3 times 3 is 3 squared. This is 3 cubed. This is 3 to the 4th. This is 3 to the 0. It works. So in an exponential function, the thing that's varying is the exponent on the base. That's the verbal takeaway, if you want to scratch an answer down for that. We're going to explore this more. In an exponential relationship, the thing that's varying is the exponent on a constant base. It's almost kind of the backwards of a quadratic, where the thing that's varying in a quadratic is a constant exponent on a variable base. It's almost like backwards. I'm going to say it again. Right, it's just, the variable in an exponential is the exponent. That's the thing that's changing. The base is remaining constant. I know a lot of you didn't like the way we did some of these formulas in the Excel spreadsheet today, where we had the time element being the variable, but that was so good because that let us see what was actually going on exponentially. Colton, go!
Can you just explain what's the base?
The base is the constant number that is being,
Okay, cool.
having the exponent applied to it.
Yeah.
Our bases today were all the 1.02 things. That was our base today. 1.02, 1.02, 1.02, 0184, 0.12, 01777. I'm making up numbers now. 1.02, 019. Those were our 0.1. I'm gonna stop. Does that make sense, Cole?
Yes.
It was a fantastic question. Thank you. We are out of time. I was going to go back to the future reference and wait till Monday. I know, I'm sorry. Shit. Actually, that clock's a little fast. I'm looking at the computers. Computers are saying 10. That makes 10:01. Shit, I'm winning over. I suck. Okay, go ahead. Drop your quizzes. Yes, right there is fine, Donovan. You make the pile. That's perfect. I got hunters here. This is great. Actually, that's a warm-up here. Thank you, my friends. Remember the exam. Don't forget your exam and email me if you get stuck with anything. Yes? Thank you. Also, let me know if you get Blackboard issues. Blackboard's been on the rampage the past week. I have no idea what the hell's going on with it. Oh, bye-bye, people at home. I'm walking around and yelling without you. We should say bye.